here's some more review for your semester 1 final in geometry. This is the unit regarding proofs and parallel lines. And so we did a lot with lines and graphing and writing parallel and perpendicular lines. So I've written down a couple things in this note section to help you out. This is your slope formula. Point slope form, this is an equation of a line. Y equals mx plus b, a different form of an equation of a line. And then these two notes about parallel versus perpendicular. So perpendicular lines have opposite reciprocal slopes. There's an example to remind you what that is. The sign is opposite and reciprocal means the fraction is flipped. Parallel lines have the same slope. The other part of this unit was proofs involving parallel lines cut by a transversal. So I'm going to pick out some angle pairs here and give you kind of a reminder of what our different angle pairs are. So when parallel lines are cut by a transversal, corresponding angles are congruent. Okay, so an example of that would be like angle 1 and angle 5. Corresponding means they're in matching locations. So both 1 and 5 are in the top left of their respective intersections. So I'm going to put an example here. Angle 1 congruent to angle 5. Okay, what else I have is I have alternate interior angles. I'm going to write it out so you remember what these are, but you guys are welcome to use the abbreviations. Alternate interior angles are congruent. Okay, so an example, alternate interior. Alternate means either side of the transversal, but in between the parallel lines. So 3 and 6 would be an example. So angle 3 is congruent to angle 6. We have alternate exterior. Are congruent. So alternate still means alternate side of the transversal, but this time they're outside the parallel lines. So an example of this would be angle 1 and angle 8. Okay, so these are the three kinds of pairs we have that are congruent when I have parallel lines cut by a transversal. We also have a pair that's supplementary. Those are same side interior angles. Are supplementary. So an example of that would be same side interior, so same side of the transversal, and in between the parallel lines would be like angle 3 and 5. So their relationship, instead of being congruent, when I add them together, they sum to 180 degrees. So that is the relationship for same side interior angles. Okay, so we're going to do a couple examples here. You are going to have a proof on your exam that's really similar to this one. It's going to ask you to prove something about angles given parallel lines cut by a transversal. So I'm going to set up my 2-column proof. Remember, we want to start with what's given if we are given anything. Here, there's not a lot that's given except for these arrow markings, right? Let me know those lines are parallel. That's a good starting place because that means all those angle pairs have those relationships we want when those lines are parallel. So I'm going to start with that. I'm going to actually add some labels here, you guys. I'm going to label those lines A and B, okay? Just so I can talk about them in the proof. So I'm going to say A is parallel to B, and I'm going to say that that's given because of those arrow markings in the picture. Okay, next, we know something about these two angles, and I'm maybe going to add one more letter up here. Let's add a G so I can talk about that angle. So I'm adding a point up above, you guys. All right, right there. Talk about that angle. Okay, so we have this angle right here and this angle right here. What kind of angle pairs are those? Well, they're either side of the transversal and they're in between the parallel lines, so those are alternate interior angles. So I'm going to say that angle GDE, so this piece right here, is congruent to FED, and the reason is because of the alternate interior angles theorem. Okay, now we want to show that DEF is 62 degrees, so we need to get to the point where we're using the equation and solving for x. So I'm going to go ahead and substitute here, and actually, instead of congruent, you guys, I'm going to go ahead, well, we'll leave it. We'll add in all the steps so you can see it. So remember to go from congruent to equals, we use the definition of congruent, so I'm going to replace congruent with equals, using the definition of congruent. In this case, I'm talking about angles, so I'm going to say definition of congruent angles. Now that I'm in an equation mode, now I can substitute these expressions in. So I can substitute in 8x minus 34 equals 5x plus 2. So I'm substituting those expressions in for the angles. So substitution is the property I'm using. Okay, and now I'm just going to solve this equation. So I'm going to use my properties of equality. I'm going to start by subtracting 5x. Okay, and I'm actually going to do this in one step. I'm also going to add 34. So I'm using both the subtraction and addition POEs there. I'm doing it in one step. You can certainly do it in 2 different steps. So now I have 3x equals 2 plus 34 is 36 when I simplify. All right, and now I'm going to divide both sides by 3 using my division POE. So I now have x equals 12 when I simplify. So the last thing I need to do is show DEF equals 62 degrees. So DEF was 5x plus 2, plus 2, and I'm going to substitute in 12. So the measure of angle DEF equals 5x plus 2, but we're going to put 12 in for x using substitution. And when I follow order of operations and simplify, I do get the measure of angle DEF equals 62 when I simplify that. And that is where I wanted to end. That's what I was trying to prove, so that should be the last step of my proof. We are done. All right, number 2, write the equation of a line that's perpendicular to this one, and it goes through this point. Okay, so let's start with what we know. This line, what is the slope of that line? Well, it's in y equals mx plus b, slope-intercept form. My slope is the number in front of x, 2 in this case. This is a point x1, y1. So I want it to go through this point, and I want the slope to be perpendicular to this one. So if my slope is 2, that means the perpendicular must have opposite reciprocal slope. So if this is really 2 over 1, positive, opposite would be negative, and reciprocal would be flip. So this is the slope I want to use to make sure it's perpendicular, and I need it to go through this point. So because I have a point and slope, I'm going to put it in point slope form. So I've got y minus y1 equals my slope times x minus x1. I can simplify that to just addition. So you are welcome to leave it like this. This is point slope form. This satisfies the problem. But if we were asked to put it in slope-intercept form, remember we can distribute here and get y by itself. So I'm going to show both just to leave it. So this one would be point slope. This would be the answer in point slope form. If I want to get slope-intercept, I'm going to distribute my negative 1/2. So I get negative 1/2 x, half of 4 is 2. And then I would subtract 3 from both sides. So I'd get y equals negative 1/2 x minus 1. So this would be slope-intercept. So depending on how you are asked for the answer, you might need one or the other. If they don't specify, you could do either one. Okay, so that is it for this unit review. Thanks for watching.